Alright, Chapter 8, Pre-Engineered Structure Buildings, K-Span Towers, and Antennas. As Steelworker pre-engineered metal structures special interest to you, explain some of the disassembled rigid frame buildings, K-span steel towers, and antennas are some of the most commonly used structures, particularly in advanced spaces. This is oversea. All pre-engineered structures discussed in this text are commonly designed structures fabricated with civil industry conform specification armed force advantage pre-engineered structures. As they are factory built designed to be erected short pause time. Each pre-engineered structure is shipped as a complete building kit, including the necessary materials and instructions to erect it. Various types of pre-engineered structures available to numerous manufacturers such as Strand Corporation, Pasco, Butler, and however they're similar with the because each military specification would not be practical to try to include all structures that each company fabricates. Therefore, the manual description basic procedure for erecting dismantling 40-foot by 100-foot building is provided as an example. Pre-engineered buildings. The chapter introduces you with the design structure procedure for the erection of a typical pre-engineered building, or PEB. The K-spans and pre-engineered antennas and towers. Pre-engineered metal building figure 8-1, 40 feet by 40 feet long. Although the unit length of the building is 100 feet, the length can be increased to decrease multiples of 20 within which call their 20-foot bays. True building length will be equal to the number of 20-foot bays plus 6 inches. Each end bay is 20 foot, 3 inches. The building is 14 foot high with a cave that's 1 foot, 8 inches and rigid. Pre-engineered buildings are ideal for use of repair shop warehouses because of their large clear floor without columns or other obstructions as well. Inside straight sidewall design allows you floor to ceiling storage material, wall-to-wall placement of the machinery, column-free interior permanent, sufficient shop layout, unhindered production flow. After building is up, there can be a large wall used for the bays to provide additional space under one roof. The desired buildings can be erected side by side. Multiples when building is no longer needed can be disassembled, stored, moved to another location, re-erected. Because only bolted connections are used, no field riveting or welding. Rigid frame and strong it is designed for. Figure 8-1 shows a completed 40-foot by 100-foot, 14-foot pre-engineered building. Working loads of 20 pounds per square foot load, dead load, and loads up to 70 mile-an-hour wind. For building can easily modify varying lengths for purpose of taking out the adding of the bay, substituting various foundation wall sections, bay the distance between two column center between the end wall, first column center, and the end wall. Formulas used to determine the number of the bays and frames of intermediate frames buildings are as follows: length divided by 20 number of bays, bays plus 1, total number of frames, total number of frames minus 2, number of intermediate frames, pre-erection work. Extensive pre-erection work is required before you start with the actual erection of the building. After the building site is located laid out by the engineering aides, it will be cleared and leveled. The equipment operators' batter boards are set up with the pairs of which each the corner of the foundation is located. Builders fabricate with the form of the concrete. Steel workers are cutting, bending, typing, placing, reinforcing steel. In the particular building requires underslab utilities. This is plumbing and electrical services. Utilities men and construction electricians will also be on the job site last, and all underslab works must be completed as pass all quality control inspection before concrete is placed and finished. Most importantly, as far as ease of erection is concerned, before the concrete is placed, templates for the anchor bolts are attached to the forms, and the anchor bolts are inserted through the holes in the each. Next, the forms are tied to try to make sure that the remaining vertical will be struck at this point with the proper placement. The anchor bolts are absolutely critical in the erection of the PEB pre-erection building. You will only have the tolerance plus minus 1/8 of an inch of the worked width. The threads of the bolts are greased and the nuts are placed on them to protect the threads. Concrete is poured in the form. Work carefully into the placement of these bolts, so that they remain vertical and play finally according to the plan specification. Slab is poured while the foundation is being prepared for the crew's leader, as well as be assigned personal crew to perform various types of preliminary work, such as uncrating inventory of all the material with the shipping list of the bolting and up rigid frame, assembling door, even glazing windows. Box 1 containing the erection manual. The drawings, the inventory list, and should be opened first. If all the preliminary work is done correctly with the assembly erection over the entire building is accomplished easily and quickly. All material except the sheeting should be uncrated, laid out in order, manner so that the parts can be located easily. Do not uncrate the sheeting until you're ready to install it. When opening the crates, you use care not to cause undue damage to the lumber. This is important since the lumber can be used for sawhorses, various other items around the job site. In more situation, after building formation has been prepared, building materials should be placed around building site with the new location where it will be used. Action provides greatest accessibility during assembly. Girths, purlins, cave struts, brake rods should be equal, divided along both sides of the foundation. 8.2 shows material, shows the girdling parts and leaves and struts, brake rods, the miscellaneous parts, panels, miscellaneous parts. Panels and miscellaneous parts which will either immediately should be placed on each side of the foundation pallets, give the covered with the tarps and similar type of the covering until the pallet needed. Parts making up of the rigid frame assembly laid out ready and assembly with the position raised, and care should always be used the unloading material. To remember the damaged parts will cover the delays in getting the job done. To avoid damage loads over the material ground floor, do not drop them. Figure 8.3 help with identify the structural member of the building and their location. Each part with a special purpose must be listed and installed with the location care of the ensure the sound structure. Never omit any part called on the job to detail the erection drawings. Each of the members and parts accessory of the building is labeled and stenciled so it's not necessary to guess that one goes where, whether further the erection plans found with the particular members as you need the work. Erection procedure. With all the precautions work completed, inspection and past quality control, as well as your inventory completed, you are ready to start erecting the pre-erected building. This phase of the or discussion is introduced the basic erection procedure. The reason for this instruction give you a general guide of the file. Keep in mind the drawings provided with the manufacturer must be followed in all cases, even when they're made to differ for the information in the training manual. Manufacturer's standard practice is always to pack the erection manual and set of the drawings with a small part box, one shipped with each building. Bolting rigid frame. Bolting up the rigid frame is slowly clean all the dirt debris with the top of the foundation. Lay out the bolt of the bag shoes firmly to the concrete. Use 5/8" black steel washer between shoes and nuts. Lay out and assemble the column, roof beam, each pair of the base shoes, using 3/4 inch, 1.5 inch bolt on each side of the base shoes to act as pivots to raising with the frame up. Use drift pins as necessary to line up the holes. Frame erection. Gin pole can be used to raise the end of the frame of the building to prevent the distortion. Alright, figure 8.3 shows a structural member. You have the base angle of the brake shoe, the side bracing walls, the girts, the sag rods, the angles, the girts, the window angles, door guides, door post, door header girt, door track girt, louver angle, lover angles, boot roof beam, rigid frame, roof brace rods, purlin, eave struts, roof sag rods. Figure 8.4 shows a frame assembly, 5/8" steel washer, black base shoe, frame when it's raised up, the test provided securely each of the frame below the splice connection, also rigid to the roof beam. To drop a drift pin in the flame shown in figure 8.5 to prevent burtle from slipping up. Set the gym pole over the block. If the gym pole is not available to take a 2x6 and 20 feet long from the longest shipping crate in the air of the and nail them together. Attach a tagline name and show in figure 8.5. Now pull the end of the vertical position. Even the crew of 4 or 5 people, the erection line, a tag person should have something to couple. Search your drift pins, eave strut, the tagline, eave strut, and it shows the frame erection. Turn around so that the bumper struck within end of the frame should go beyond with the vertical tag person should be able to keep it from falling. To get a frame started from the ground, it should be lifted so the people propped up as high as practical, but bolt the cave strut and each column is shown in figure 8.5. Cave strut allows the frame to be propped up every stage of the lifting. After the frame in the vertical position, install with the guidelines, drop props into cannot move. Now raise the second frame in the same way, hold it vertically and play with the install on the purlins, girt, and brace rods. A crane other than suitable type of the power equipment that can be used. The hoist or frame within place with the touch of the equipment is available. When the power equipment is used, the suggested procedure comply with the files. Raise the columns, bolts within base shoe to break them within the plane and shovel the sidewall girts. Keep the columns as rigid as possible. 3, bolt the roof beams together and shovel the gable posts and wall headed forward. Secure with the guidelines, taglines for the roof of the beam shown figure 8. 6 attached with the wire rope slinging approximately center each of the roof beam. 5, the hoist of the roof beams into the position with half of the column bolts with it. Both them in place. 6. When the second rigid frame section secure with the position, show all of the roof purlins, gable the angle with the lower angle, attach the gable clips to the purlins before raising it into position. 7. Install with the brace rods aligned with the first bay, that must be aligned before with the erecting. Additional brace rods. The brace rods must be installed with the first base erected with the rods are paramount importance. Since they hold the frames in the upright position, there should never be omitted diagonal brace rods attached with the frames in the roof sidewall 3 with the slotted holes provided. Use a half-round brace rod washer or flat or steel washer under the nuts at each rod. Figure 4, 8.6 shows using power equipment. Shows the column, a girt, and guide line, tagline, roof beam assembly, and temporary prop. With the rods installed with the plane, each frame column of the carpenter split level. Check for the distance diagonally from the upper corner of the one frame and the lower corner of the adjacent frame. When the distance is the same with each rod of the columns will be plumb after the side walls are run. Rods are installed with the roof rods. Length of the roof rods can be adjusted for tightening and releasing of the turnbuckle. When two diagonal measures of the same, the end bay will be square. After two frames have been plumbed with the brace square with the diagonal rod with the purlin girts and the eave struts have been installed with the guidelines and props that can be removed. The remaining frame with the building can be erected. Trade with the next frame and attach the blocks to the last frame or eighth. Do not omit with the diagonal brace rods that are required to the last bay of the building. Be sure the bolts of the girth and purlins with the cave struts inside of the holes of the end frames. Install with the cave struts, girts, and purlins in each bay as soon as the frame is erected. Extra with the care to see with the diagonal brace rod at the top, but do not project beyond the flange of the end of the frame and interfere with the end of wall sheeting. Figure 8, show the brace rods, brake rods, flat washer, beveled washer, brace rod, sag rods. Sag rods are used to hold the purlins and girts in a straight line. First, install the sag rods to come with the two purlins ridged to the building. Each rod must be attached with the top of the hole, one purlin through the bottom of the hole, adjacent purlin. Use two nuts each end of the sag rods, one each side with each of the pair, and adjust the nuts with the rod so the purlins are held straight. The ridge of the next install with the sag rods between the purlins, with the rigid rod attached to the top of the hole, upper purlin through the bottom hole of the lower purlin, upper two nuts with each of the end of the wedge with each side with the purlin file with the same procedure side wall sag rods. Remember the roof purlin should show straight line end to end of the building. Do not tighten the sag rods so much that the purlins are twisted out of shape. Alright, brace angles. After two or more bays have been erected, part of the erection crew must be installed and assigned to the install of the diagonal brace angles. Shovel the brace angles, lay with the notch portion again with the frame flange, bended it into position. Diagonal brace angle with the knee over the inner flange of the frame. They should install them so that they are taut. While some of the members of the crew are installing the brace angle, with the other members can be installed with the base angle with the sign with the duty in the first and sweep it off at the top of the concrete foundation. Base angles will sit down evenly with the bolts over the base angle in place with a flat steel washer will under the nut. Leave the nut loose to the permitted later adjusting after the wall sheeting has been applied. End wall framing, doors, and windows. Refer to the manufacturer specification proper to some of the installation procedures for end wall framing, door, bolt sliding, and roll up. Figure 8H shows diagonal braces. There's a purlin, an eave strut, and a girt. Caution, never omit diagonal braces. They are needed to support the inner flange of the frame installed with them and so that they are taut. Windows, these procedures will be available to building options. Sheeting, both side wall of the roof must also be started with the end of the building toward which the prevailing wind blow. The action ensure the exterior joint with the side walls of the way for the blowing prevailing winds installed with the roof sheeting. Always give the generous amount of the mastic upper side of the all roof just after before moving them to the roof. Turn the sheet over to put the bead of mastic on the lip of the one side of the corrugation along one of the end. Near the end of the needle for more than 1 inch from the end of the bead sure to apply with the horizontal bead mastic between all the sheets. The inlet below the lap of the whole roof shop sheet must be dried with mastic. Apply with mastic. Extremely important care should be exercised whenever they're applying it to ensure watertight seal. Apply generous beads, especially at the corner sheet. Finally, the rigid cap will be installed with ensuring proper watershed of previous stated information in this manual. General information common pre-engineered buildings. Building installation. Pre-engineered building can be insulated by any simple method. To blanket type of the installation, 2-foot wide strip with a mass of the width of the roof of the wall sheet. The canal installed between the sheets. Structural at the same time sheeting installed or hardboard insulation can be applied directly to the inside surface of the structural, attaching it by helix nails and sheet metal screw with the holes and prepared drilling of the structure of the wood framing can be prepared attached to the structural and hardboard insulation nails of the wood. Alright, building set side by side in multiples. Pre-arranged buildings can easily be set up side by side to increase the working area under one roof. The dome with adjacent rigid frames shall be bolted back channel space with each of the girt location. Figure 8-9 cave struts are moved up the roof beam to second and 11/16 of an inch diameter holes to provide gutter arrangements. Provide a space between the cave struts with 13.5 inch of the field fabricated gutter in can be installed with a flat painted galvanized steel 24 to 26 gauge material should be used with the gutter. A depth of 6¼ inch for the desirable downspout located at the required gutter ends should be lapped at least 6 inches. Show the debris braze well with water tightness. The note that the wall sheet should be used to form a gutter if the outside corrugation flattened. All of the end of the laps are braze welded. Roof sheets must be cut shorter when they are overhanging the gutter corrugation, clothed with a continuous rubber closure of the masthetic applied with the top of the bottom surface of the closure. Alternate method of flattening corrugations of the gutter and seals them with a glass fabric set in plastic. So it shows the eave struts are bolted higher on a frame to mark the gutter space, and it shows the channel spacer, shows the gable flashing, and 8-9 buildings side by side. Disassembly procedure. Disassembly pre-engineered buildings should not be difficult. Once familiar with the erection procedure, the disassembling may be carefully, clearly marked number of all the parts. You now know where the parts go. When reassembling of the building, many steps of the disassembling procedure is followed. Remove the sheathing, remove the window, the door, leave at the end of the wall, remove the diagonal braces and sag rods, remove the braces and girts and purlins, let down the frames. K-span buildings. Alright, K-span buildings are new form construction within the CBD community. They're intended to use these buildings with the flexible of the pre-engineered building discussed earlier. The AMB 120 system, K-span building system consists of the self-contained metal building manufactured plant over the AB 120 system, an automatic building machine 120 machine with a rounded mount on the trailer found on the top of the mobile factory that is easily towed, even though the remote lift construction site. Important aspect of the machine is that it can be transported by anywhere in the world easily. In fact, the ABM system has been certified with the Air Transport U.S. Air Force C-130, C-141, C-5 aircraft. Once the machine is delivered on site, they can be set up minutes, turn coils into the steel and the structural. Show the typical K-span building. Strength arc panels. The panels around the machine strengthened together with a form of economical watertight steel structure. The final shape, strength of the materials, either the cancel for the columns and beams, the other type of the interior support. All of the panel connection joint, either the electrical automatic seam machine. Because of this, there are no nodes, both any other type of the fastener slow down the construction, create leaks. One is delivered to the job site on site. The manufacturer builds the machine with the AB operator, complete construction, fabrication, as well with the quality building, the train key for the personnel, and the operation, all related to K-span equipment that is essential for the crew members. Once trained, can instruct other members of the crew in safe fabrication and erection of the K-span. Following section gives you some of them, but not all of the key elements associated with the K-span construction, all as well with all equipment, all also refer to manufacturer manuals. Alright, operating instructs the main component with the K-span system and the trailer-mounted building machine. Figure 812 of the figure shows the main component for the trailer. The general operating instructs the preliminary position operation station in the rear of the trailer. With the crew members selected for the position must have a thorough understanding of the machine operation manuals from the position. The operator controls all of the elements required to form the panels. First, the operator must run a coil stuck from the machine to form a panel shape. Next is cut for the correct length. The length is required length of the on-arc panel to run continuously with one foot over the other. Last, after the panel is cut, the length is run back through the machine to give it an correct arch. Operator must remain in control at all times from the placement of the trailer on site with the completion curve panel, attention with the detail of the paramount as well with the aspect of the construction. As you operate the panel, you will adjust the various machine operation components, adjust them thickness, radius. The curving machine must be made in according to the manuals. Do not permit shortcuts, adjustments, any variation adjustments. Disregard the instructions found with the operating manuals will leave you with a pile of useless materials and inconsistent building. Or the MIC 120 automatic building machine. Shows a round table with adjustable legs, a guillotine shear, P120 panel forming machine, produce straight panels, operating station 25-foot trailer bed of 3 axles, C120 curving machine, produce curved panels, run-out table with adjustable legs, an engine, coil stock, and primary run-out table. Shows the trailer-mounted machinery, side and rear view, and top view. Figure 813 shows the rear of the K-span trailer. Machinery placing, pre-planing the site layout with avoid setup problems, uneven slope ground is not. Concern is along with the bed of the trailer, along with the general layout of the existing strip of the condition. Even the figure 814 as a guide to the placing of the machinery. You should consider the factory for the such found with the maneuvering room of the towing of the trailer, the lever attached to the vehicle. The length of the unit is 27 feet 8 inches from 7 feet 4 inches wide. Allow enough room to run out stands and hold in the straight panel stand. The stands have then netted the length of 9 foot 6 inches. Find a point X from the center of the curve. Measure the distance equal to the radius line from the curve form with the point X for the scribe then equal to the radius. The arc is defined with the path of the curve panel. Add 10 feet for the run out strands and legs. D. Stored areas required to store with the coil stock. X if the equipment and the load on the machine. E. And then it shows A, B, C, E, D, and E, or job site exceeding 64 feet, 20 feet high, 100 feet long, radius 36 feet, panel length to 82 feet. machinery placement calculations. Direction curve panel must be carried after being formed. Level area required by the layout panels on the ground. Seaming the buildings will not be consistent in the panels will not to be straight within the seaming space required with the crane operation eye to eye. Foundation design of the foundation case span building depends on the site of the building, the existing soil condition, wind load of the foundation building, simple, easy to construct, even the distribution load of the standard arc building site of the continuous stripping footing, and in small but therefore more economical foundation, more conventional building, the concrete formed accessory building, provided are sufficient to form foundations of the building 100 feet by 550 feet wide for the different configuration required the forms available for the manufacturer. Actual footing construction is made for the all add project, the plan, specification, location of the form placement, steel, and the pounds per square inch of the concrete is critical. The building panels welded to the angle of the foot before the concrete is placed because of the operation of the aspect of the footer construction must be completely checked for the alignment of the square and if the one concrete panel will span no way correct errors. As mentioned above, the form provided with the foundation, you table 8.1 is guide with the figure 8.15, give you simple foundation layout with the parts of the explanation is noted in figure 8.15. The cross pipe is provided in the kit, but it must be ordered with a project plan and estimated. 8.1 concrete forms included in the kit. Side forms 1 by 10 foot by 12 inch gauge steel. Transition panel 1 foot by 12 inch by 12 inch gauge steel. Transition panel 1 foot by 28 inch 12 inch gauge steel. End wall caps 1 by 15 inch 12 gauge steel. Side wall caps 1 foot by 19 inch 12 gauge steel. Filler form 1 foot by 12 foot 12 inch gauge steel. Sidewall inside 1 foot by 12 inch by 12 inch gauge steel. End wall inside stop 1 foot 12 inches 12 inch gauge steel. Stakes 1/4 inch diameter bar steel. All thread rods 1.5 by 13 by 18. And hex nuts, hex bolts, hex nuts, and flat washers. Alright, show the foundation forms assembly. End wall of the pipe not supplied in by the contractor. Section A. Typical flange assembly and arch wall. Building and erection. When the placement of the machinery forming the building panel with the process for the conservation placement with the weightlifting capability with the crane. Check with the weightlifting truck with the crane with the maximum weight capacity to dictate with the number of the panels you can safely lift. Operating distances for all cranes attempting to lift more than rated capacity can cover the crane to turn over, detaching the spread bar of the figure 8.16 and cover the form panel with a critical slip failure to clamp the panel tightly can cover the panel to slip fall with the potential harm to personal damage of the panel. When guide ropes attached, figure 8.17 personal manning these ropes, and if the panel's placement with lifting high as high with the necessary position 2 minutes at the free with the guide them in place. Remind the crew members to keep their feet under the end of the arc and never attempt to lift any set of panels in a high wind. So place the first set of panels on the attaching angle of the foundation, position them also that they were in room, the end of the panel at the position, first step set panels, clamp it in the angle of the plumb of the guide rope, secure with the ropes previously anchored stakes to detach the spread bar, continue to place the panels, each set with the standing panels attaching the spread bar. After 15 panels, 3 sets are placed in place. Measure the building length of the both ends just above the form at the center of the arc. The measurement itself of them must be 1 foot per panel, usually slightly more, but should be equal to each of the panel. Just each end of the equal to the center. Measure the panel flexible enough to adjust slightly. Check with the measurement periodically during the building construction place because the exact building lengths are difficult to predict. End wall attaching the angle of the finishing end of the building should not be placed until all the panels are set. After arches are in place, set with the longest end of the wall panel when the form plumb and the clamp it into place. Work this from the longest panel outward and be careful to maintain plumb. When all the building panels are welded in attaching angle figure 18 and 12 inches on center, you are ready to place in concrete. When you're placing the concrete, remember the extremely important to well vibrated the action and eliminate the voids under embedded items. The concrete begin with the set the slope at the top, exterior of the portion of the concrete capped about 5 inches. Allow the water to drain away from the building. Elevation type of the interior floor is not relevant long as the finish of the interior floor is not higher than the top of the concrete cap. The K-span building system is similar with the type of the pre-engineered, prefabricated building. Windows, doors, and rolled-up doors installed only when the erection is complete with the insulation of the building is required. Insulation boards usually 4 feet by 8 feet. May be semi-rigid material that can be bent with the match for the radius of the building, and the insulation installed with using scissors clips is shown in figure 820. When integrity of the end panels, the continuous round roof line, the end of the walls but itself, supporting insulation window 821, aluminum doors 822 with the present no problem because of the integrity of the wall system is not interrupted. Installation overhead door figure 823 doors present. The problem does not interrupt the integrity of the wall system. Situation quickly overcome by easily installed with adjustable height of the width door frame package. This supports both the tower door and end wall of the door frame and is offered with a manufacturer shown in figure 824 with the fundamental steps of the construction case span with the start to finish. The ABM 240 system. There's another type of the K-span building actually referred to as the super span, but the manufacturer ABM 240 actual construction for the ABM 240 is the same as the AB 124 K-span. Uses a heavier Kohler stack, larger version of 825 gives to show the difference between the two. Keep in mind that the information provided in the section K-span building is basic. During the actual construction of the building, you may consult the manufacturer's complete set of manuals. And shows a spread bar attachment, clamps and spread attached assembly, attached to the center plate with the 4 clamps, hook for the crane, and then it shows the 12-foot approximates from center to center line, and from the center line, spread attached assembly, spreader bar attachment, guide rope diagram, 10-foot approximate from the center lines, attached rope first set of panels, erected guide rope, and then it shows the typical guide panel connection. Then we're going to look at this in a second. Show the miscellaneous, the MIC curved panels, welded panel to attaching angle with a resistance, cross pipe, reinforced bars attached cross pipe, building erection concrete foundation forms, panel attached angle, welded to cross pipes, upgraded foundation form, stake 3/4 of an inch, concrete foundation slope approximately 5 inches from water drain, building foundation concrete. Then we're going to flip it backwards. This shows the concrete foundation, the curved panel, the concrete foundation panel attaching the angle, and show the subgrade foundation concrete floor level, reinforcement guards, continuous cross pipe, members, panel attachment angle, welded to cross pipe. Shows curved panel, fast clipping, variable length, insulation black, extruded plastic, eye strip, protective clothing, insulation variable thickness, aluminum window details, wall system, aluminum door details, wall system. Show the overhead door frame. Show step 1. Level site foundation form, prepare for a foundation. Load coil stack on machine, feed it through. 3. Form the straight panel through the rollers. 4. Automatic stop measure panels to precise length. 5. Cut panels desired length of the guillotine shear. 6. Turn straight panels on the edge, feedback through the curver. 7. Seam curved panels together horizontally on ground. Step 8. Hoist lifted group of the panels into position. Step 9. Seam new section of building on existing sections. Step 10. Weld newly placed arches onto foundation. Step 11. Trim and fit end wall doors to position. Step 12. Finally pour concrete above the grade foundation. Alright, this shows coil stock width, maximum steel thickness, panel profile, maximum span, minimum span. Alright, steel towers. Cut the tape there.